Okay, I've been asked about this problem from section 4.1. It says an engineer wanted to determine how the weight of a car affects gas mileage. The following data represent the weight of various cars and their gas mileage. And you can open this data in StatCrunch, as you can see by this icon here. All right, so if you open this data in StatCrunch and do a dot plot of it, it looks like this, choice D. And we can also compute the linear correlation coefficient in StatCrunch. So we can open this in StatCrunch. Here's the data, and then we can go stat, regression, simple linear, and the x variable is the weight of the cars, and the y variable is the miles per gallon that those cars get. And we can just hit compute, and it gives us lots of information, including the R right here, the correlation coefficient, which is negative 0.9458. If we round that to 3 decimal places, it's negative 0.946. That's the correlation coefficient. And what that tells us, since the R is negative, it's telling us that the points are somewhat in a linear pattern going down from left to right. So what the negative tells us is that the points are somewhat going down as you look from left to right. So we fill in the blanks in part D this way. Because the correlation coefficient is negative, and the absolute value of the correlation coefficient is, so in this blank, you drop the negative because they ask for the absolute value. So you drop all negatives when it asks for the absolute value. So we just give it the 0.946. And the reason you drop the negative is because you only want to use the positive value, the 0.946, when you compare this to what's called the critical values. So if I go back over here and open up the critical values, I want to compare this positive value to the critical values on this chart, which are all positives. That's why we drop the negative when we go to this chart. Now this problem had, if I count the points that we were given, 1, 2, 3, 4, 5 points. There were 5 data points. So I'll look on the chart for n equals 5, and I get a critical value of 0.878 from this chart. So I do have to use this critical value chart. Now I compare the 0.946 to this value 0.878. As long as my original correlation coefficient is greater than 0.878, this is telling me that these points form a pattern that's close to a straight line. The R value tells you kind of how close you are to a straight line. As long as it's greater than this 0.878, we know we have a pattern that's pretty close to a straight line. So we fill in the blanks in this way. Because the correlation coefficient is negative and the absolute value is 0.946, and that's greater than the critical value from this chart, which is 8.78, then we know a negative linear relationship does exist between the weight of the car and its miles per gallon. So we're saying as long as our correlation coefficient, as long as the absolute value is greater than this critical value from the chart, then we do know that we have a linear relationship, which means it's pretty close to a straight line. And it just happens to be negative in this case because the points are going in a downward pattern. So I hope that helps you understand this problem. So the R can be negative, but you just use the positive value when you look on the critical value chart and compare it to the critical value. So I hope this helps.